We've been looking at how equations, tables, and graphs relate. You've actually graphed several different types of equations, both linear and nonlinear, by making a table. So if you encounter any type of equation, you can always make a table of values to help you graph it. But today I want to show you a trick, and this is a nice thing to help you write equations and graph equations. So let's look at the slope-intercept form. So y equals mx plus b, we have the slope, which is the rate of change. That's going to be the coefficient of x, and the y-intercept will be b, and that's the starting value. So we want to write an equation for the line. So let's look at the graph and see what we can figure out. The y-intercept, where the graph intersects the y-axis, is 0, -1. So that means that b is equal to -1. What is the slope of the line? So recall that the slope is the vertical change divided by the horizontal change, or the change in the dependent variable divided by the independent variable, or the rise over the run. So let's create our triangle here, and I'm going to do it on this side. So from -1 to 3, how many units do we have? That would be 4. And from 0 to 2, there are 2. So the change in y divided by the change in x is equal to 4 divided by 2, which is 2. So the equation of our line, all we're going to do is substitute 2 for m and -1 for b, and recall that x and y are all the coordinates, help us identify all the coordinates on this line. So we have y is equal to 2x minus 1, where x and y are our variables. So what I'd like you to do right now is pause the video and write the equations for both of these lines. Now let's look at how we can use the slope-intercept form of the equation to actually graph. So we've looked several times at the video streaming problem, but let's look at what we know. So if we have y equals mx plus b, the slope is 2.5 since it's the coefficient of x, and the starting value, or y-intercept, is b, is 7. So that helps us because we can go directly to our graph, and we can go to 7 and graph 0, 7. That's our y-intercept. So this is going to be our starting value. Okay, and then we can go up the graph. We can go up 2.5 and over 1, and that will give us 1, 9.5. So you can see how that relates to the table here. And then 2 is up to 12, and then 3 is up to 14.5. Okay, so this shows you in context what the graph will look like. So let's try one that's a little bit more abstract. So we want to graph using the slope-intercept form. So let's see what we know from our equation. So the coefficient of x is a ghost 1, so that's 1. So the slope is equal to 1, and the y-intercept is -2. So let's use those to graph. So always label your graph. And we'll start with the y-intercept. The y-intercept is -2, so I'm going to graph it right here. And the slope is 1. But recall that 1 is also 2 divided by 2, or 3 divided by 3. So I can go up 1 and over 1. I could go up 3 and over 3, just as long as it is puff, puff, positive, like the video. So now we know the y-intercept, and we know other points on the line, and voila, we have our line graphed. So let's just see how this relates to the table, if we have our input-output table. So let's find f of -1, for example. We'll have -1 minus 2, and that gives us -3. So -1, -3. If we have f of 0, that would be 0 minus 2. So that's -2. Or f of 1 would be 1 minus 2, or -1. So if you notice, we have -1, -3, 0, -2, and 1, -1. Those are all points on our line. And if you notice how the table relates to the equation and to the graph, our y-intercept is when x is equal to 0. So that's -2, -2, and -2. So what I'd like you to do right now is pause the video and graph this equation, y equals -3x plus 1, using the slope and y-intercept. The final thing that you can do with slope-intercept form of the equation is you can solve an equation for y and put it into slope-intercept, and that can be very helpful. So if you notice, if you tried to use x and y-intercepts here, the y-intercept would be really easy, because if you let x equal 0, y would be -3. But the x-intercept is a little different. If we let y equal 0, x is going to be 3/2. So I don't really want to graph a fraction, so let's actually solve this equation for y. So in order to solve for y, we're going to subtract 2x from both sides, and we have -y is equal to 3 minus 2x, but we can never leave a -y here. So in order to change this to positive, we need to multiply both sides of our equation by -1. Don't forget to put parentheses around everything. So we have y is equal to -3 plus 2x. And because of the commutative property of addition, I can say 2x plus a -3, which is 2x minus 3. So let's graph that, labeling our graph. So we have our y-intercept is -3, and our slope is 2, and remember, it has a ghost 1 underneath it, so it's 2 divided by 1. 2 divided by 1, 2 divided by 1. So rise over run for our slope. And then our equation is graphed. So your final challenge is to graph these two equations using the slope and y-intercept. Make sure that you use graph paper. And then you have one more question. It says, if you are graphing any equation, and I mean linear or nonlinear, what can you always do?